Okay. This is section 6, topic 7. Factoring polynomials. Target, how do you determine what method to use when factoring different types of polynomials? What are the steps to factoring polynomials? So on this one, we don't really have many words to write. It's just all problems. And like I said before I started this video, a lot of these you already know how to do. Some will be new. Some you know how to do. The only thing different is that they have added 2 variables instead of 1 variable. Okay? All right. So example 1. We have negative 2x cubed minus 6x squared plus 56x. Now we're just factoring, we're not factoring to solve, okay? If we wanted to solve, we could continue doing that, but today we're just factoring, so we don't have to take that solving step. No matter what kind of problem that you're factoring, the first question you always want to ask yourself is there a greatest common factor? Because if there is, take it out first. It's always going to be your first question, okay? So does this one have a GCF? Yes. What is it? 2. Do I have any variables? X. So this term has 3 x's, this term has 2 x's, this term has 1 x, right? Take as many x's as they have in common. So can I take more than 1 x? No. Also, if your leading coefficient's negative, it doesn't matter if they're all negative or not. Go ahead and factor out the negative as well. Okay? So our GCF, we're going to take out a negative 2x. So we know how to do this. Put negative 2x outside the parentheses. Divide each term by the GCF to see what's left inside the parentheses. So let's just take it slow. What's a negative 2 divided by negative 2? Well, just the negative 2 part. It's positive 1, right? And x cubed divided by x is x squared. So 1x squared is the same thing as x squared, and it is positive. What is negative 6x squared divided by negative 2x? And what's my sign? Positive 3x. Positive 56x divided by negative 2x. Negative 28. And do I have an x? No, I had 1 x. I took it out, so this term no longer has any x's. So you always want to make sure after you take out a greatest common factor, what's in parentheses. Sometimes you can factor it further, sometimes you can't. Usually you can factor it further. If you see a quadratic, then that's something that may be able to be factored further. If it's linear inside, where your highest degree is 1, the only way you can factor a linear polynomial is if it has a GCF. But if it has a factor higher than 1 or an exponent higher than 1, you might be able to factor it further. Like I said, even if it has an exponent of 1, if there's a GCF, you can factor it further. So quadratic, we know when we're factoring a quadratic, if it's not a special case, does this look like a special case? No. We can use the T-chart and divide and slide. But is every quadratic factorable? No. But if it is, we have to factor it. So let's define A, B, and C. We know A is equal to 1, B is equal to 3, and C is equal to negative 28. So we need two numbers that multiply together to give us A times C, which A times C is negative 28, and then add to give us B, which is positive 3. Any ideas? Say it again. Negative 4 times 7, let's try it. Negative 4 times positive 7 equals negative 28. Negative 4 plus 7 equals 3. That works. So we have negative 2x, make your two parentheses. First term is whatever variable we're using, so we're using an x. And then we have minus 4 in one set, positive 7 in the other. Do we need to divide and slide on this one? No, we can, but we'd be dividing and sliding by 1, right? And that's not going to change anything. Now, I'm only factoring. I should have put that up here. Factor. Not factoring and solving. But if I were solving, how many solutions would I have? 3. If I have 3 degrees, then I better have 3 solutions. Your number of degrees tells you how many solutions you're going to have. And that's where your graph's going to cross the x-axis, okay? If they're imaginary, if any of my solutions were imaginary, like if I had 1 imaginary solutions and 2 real, that means it's only going to cross twice, okay? And then you have an imaginary. But this is the maximum number of times it's going to cross the x-axis. You still need to have 3 solutions. So if I set negative 2x equal to 0, what would my solution be? I would divide both sides by negative 2. 0 divided by negative 2 is 0, right? So I would have a solution of 0, a solution of positive 4, and negative 7. But it didn't ask me to do that. But in the next lesson, we're going to be graphing, and so I'm just, reminding us. So it's completely factored. What's inside parentheses? This is a linear polynomial. This is linear. If it's linear, the only way to factor it is if there's a GCF. We don't have one, so we know we're finished factoring. Okay? Anybody have questions on that? Example 2. 2x cubed minus 2x squared minus 8x plus 8. You may have factored problems like this in Algebra 1, but we haven't factored any like this yet this year. Have we factored any problems that have had 4 terms? Hasn't happened. So we're going to factor this. When you see 4 terms, automatically think factor by grouping. Okay? But before we even start, do we have a GCF? Yes. What is it? 2. Any x's? Nope, just a 2. All right, 2x cubed divided by 2 is x cubed. Negative 2x squared divided by 2 is negative x squared. Negative 8x divided by 2 is negative 4x. Positive 8 divided by 2 is positive 4. Inside parentheses, that's not a quadratic, right? It's a cubic. We can't use T-chart and divide and slide on a cubic. It's only for quadratics. And sometimes if you have 4 degrees, we haven't learned that yet either. When you see 4 terms, think factor by grouping. And some of you may have learned factoring this way from a quadratic. So what you do is, we're not worried about the GCF, okay? That's still going to be on the outside of the parentheses. I'm only talking about the 4 terms inside parentheses. You want to group your first 2 terms together, and you want to group your last 2 terms together. All right, so I'm going to do all of that inside brackets because I don't want it to get confused with my GCF on the outside. Your first 2 terms, look for the GCF in those 2 terms only. If the GCF is 1, usually we don't take out a GCF if it's 1, but when you're factoring by grouping, you do, okay? You have to take out something. If 1's all there is, 1's all there is. So in just my first 2 terms only, what's the GCF? X squared. So make you a little parentheses there. I'm factoring out x squared just from those 2 terms. What's x cubed divided by x squared? X. Negative x squared divided by positive x squared. Minus 1. Okay, now look at your second 2 terms. We're going to factor out a GCF just from those, okay? And whatever the leading coefficient is of your second group, whatever the sign is, take that sign. If it's negative, take it. If it's positive, take it. So we're going to factor out a negative what? Negative 4. So I'm left with negative 4x divided by negative 4 is x. Positive 4 divided by negative 4 is negative 1. If it's factorable, what you have inside the parentheses will be identical, okay? If what you have inside parentheses is not identical, either you did something incorrectly, or if you did not do something incorrectly, it's just not factorable, okay? But what we have in parentheses is identical. So remember, right now this is 1 term, and this is 1 term, because a product is a term, okay? So this 1 term has 2 factors. X squared is a factor, x minus 1 is a factor. This 1 term has 2 factors. Negative 4 is a factor, x minus 1 is a factor. So between these 2 terms, do they have a GCF? Yes, what is it? X minus 1. So we're going to factor it out. So don't forget, we still have this 2 outside here. And at this point, I can just make 2 sets of parentheses. So I'm going to factor the x minus 1 out from both sets. So think about it. What's x squared times x minus 1 divided by x minus 1? Just x squared, right? Because you factored out the x minus 1. This term, what's negative 4 times x minus 1? Quantity divided by x minus 1. Just negative 4, that's all that's left. Now, the way I think about it, so technically we divided both of those terms by x minus 1 because that was the GCF. Because that was the GCF that I factored out. Right? This term had a factor of x minus 1. This term had a factor of x minus 1. So my GCF is x minus 1. So I factored that out of both terms. Right? Usually when you have a GCF, don't you take it out? And then divide every term by the GCF to see what's left. So what I think of, because a lot of kids get confused by that, this is what I think of. It's called factor by grouping, right? We grouped our terms together, and then at this part, I grouped my terms together. What's inside the parentheses? Put it in one parentheses. What's on the outside? Group that together in the other set. Okay? But a lot of kids will write this x minus 1 2 times. It's a GCF. I had a GCF of 2 up here. I didn't write 2 4 times, did I? On the outside, it's the greatest common factor. I took it out once. Just happens to be a binomial. So 2, you don't factor a monomial. You don't have to break that down into factors. X minus 1, can that be factored any further? No, it's linear and it doesn't have a GCF. X squared minus 4, can that be factored any further? Yeah, what is that? Difference of 2 squares. So I'm going to factor it further. So bring down your 2, bring down your x minus 1. Difference of 2 squares we know gets 2 parentheses. One gets a plus, one gets a minus. My first term is the square root of the first term. So square root of x squared is x. And the second term is the square root of that second term, which is 2. Can I factor either of those any further? Nope, they're linear. Only thing you could do is take out a GCF. They don't have one. So I'm supposed to have 3 solutions altogether. How many do I have? 3. 2 is a factor. It won't give me a solution. 2 equal to 0, not true statement. But I'll get solutions from all 3 of these, right? So I'll probably over-explain that. I don't know, but we haven't done it before, so. Okay, let's look at this next one. I'm trying to squeeze it in. We have 24 x squared y minus 6 xy squared minus 9y cubed. Okay, is there a GCF? Yes. What is it? What? Just a 3? Do all of my terms have an x in them? Does each term have an x? Just y, right? Each term does not have an x, so I can't take one of those. My first term has y, 1y. The second term has 2 y's. The last term has 3. So how many y's can I take? 1, because this one only has 1. X squared y. So I can take out a 3y. And I don't take a negative this time because my leading coefficient is not negative. So I will divide each term by 3y to see what's left after I take out the GCF. First term, 24x squared y divided by 3y. 8x squared. 24 divided by 3 is 8. X squared, there's no x's on the bottom, so it's still x squared. Y divided by y, my y's turn into 1. Y divided by y is 1, so we just say 8x squared. All right, over here, what do I get when I divide these two terms? What's my sign? So minus 2xy. Negative 6 divided by 3 is negative 2. X, I didn't take any x's out, so it's going to say y squared divided by y is y. How about when I divide my last term? Minus 3y squared. Negative 9 divided by 3 is negative 3. Y cubed divided by y is y squared. Okay? So, now, this is kind of weird because we do have a quadratic. We have 2 quadratic terms, so that's considered a quadratic, okay? When we factor it, or try to factor it, we're still going to use the t-chart and divide and slide. Don't let the variable over here trip you up. The only thing, when we make our parentheses, you know how in the first set we put an x if that's the variable we're using? And then sometimes it gets a coefficient if we slide. Well, the second term, there's just going to be a y there. Okay, if this x is squared and this y is squared and the middle term has an x and a y, we'll just put an x in the first term, a y in the second, and then we'll do the numbers using the t-chart. I know it's kind of confusing. So, in our t-chart, we need 2 numbers that multiply together to give us AC, which a times c is negative 24, and then add to give us b, which is negative 2. Now, the reason I'm recording this video and I haven't been recording the latest ones is because on the last ones you can kind of pretty much read the notes and figure it out for the most part. But on the factoring, I know kids get hung up on factoring, especially when you have all the different types mixed together. So I'm going to make sure and record it. If you get confused, go back and watch it, okay? Because I know there's a lot of different types here. But y'all pretty much know most of the rules. You just have to think about them. So, what do we have here? Negative 6 times positive 4 is negative 24. Negative 6 plus 4 is negative 2. Perfect. So 3y goes outside the parentheses. That's your GCF. Make 2 sets of parentheses. Since my first term is where the x's are, we put an x in the first term. In the last term, we have y squares. So the second term in each parenthesis will get a y. Okay? These numbers still go with the second term. So put a minus 6y and a plus 4y. All right? And I did not define my variables over here, and that's gonna, I don't want to make the mistake and say that a is 24, because right here, a would have been 8, b was -2, and c was -3, right? So do we need to divide and slide? Yes, because a is some number other than 1. So we do that just like always. The only difference is we just have that other variable. No biggie. So 6/8, is that going to be a divide or a slide? A slide. Can I reduce it? Yeah, so I have to reduce before a slide. What about 4/8? Divide or slide? Slide, but can I reduce it? Yes. Usually when you can reduce, they both end up being a slide. So let's reduce them before we slide, otherwise we won't get the right answer. So that's x minus 6/8 reduces to 3/4. Don't forget your y. 4/8 reduces to, whoops, 1/2. Don't forget your y. And then we can slide. So 3y, open parentheses, slide the 4 in front of the x. So that's 4x minus 3y. In the second set, slide the 2 in front of the x. So it's 2x plus 1y, or just plus y. And that's probably just going to take some practice to get used to doing that. Inside parentheses, do either of them have a GCF? No. They're both linear. The highest degree is a 1. So as long as they don't have a GCF, I can't do anything else to factor them. Okay? Anybody have a question about that? All right. Example 4. One minus 9y to the 4th. Do we have a GCF? I can't hear you. You don't have to. Okay. This is to the 4th degree, so we don't do T-chart, divide, and slide. Is it a special case that we know about? What? Difference of two squares, right? Isn't 1 a perfect square? Isn't 9y to the 4th a perfect square? And we're subtracting, right? So this is a difference of two squares. And it's okay that the order is not correct. If we switch the order, it would be negative 9y to the 4th plus 1. So you'd have to factor out the -1 to turn it back into a difference of squares. So I would just leave it like this and factor it like this. So difference of two squares, we know we make two sets of parentheses. One gets a plus, one gets a minus. The square root of the first term is the first term in each set. So what's the square root of my first term? The square root of the second term is the second term in each set. 3y squared. All right, so now in parentheses, this is not a difference of squares. If that was 1 minus y squared, it would be. It's not a difference of squares. Is it a difference of cubes or sum of cubes? No. It's not a perfect square trinomial. It is a quadratic though, so if we could factor it further, we would need to. So let me just check real quick. Let me put that in standard form. Would be 3y squared plus 1, right? So a is 3. What's b? 0. And c is 1. Are there any two numbers that add together to get 3 and subtract to get 0? No. All you have is 3 times 1 and negative 3 times negative 1, right? So they wouldn't add to get 0. And if I put this in standard form, it would be negative 3y squared plus 1. A is negative 3, b is 0, c is 1. Are there two numbers that could multiply to get negative 3 and add to get 0? No. So they're not factorable. If they were still factorable, we would need to do that. Okay? So that's my answer. Sometimes they're fast and easy, sometimes they're not. Example 5. I do have a lot of examples today, just because I want you to remember all these different types and get plenty of, practice. All right, 16 m to the 4th minus 72 m squared n squared plus 81 raised to the 4th power. Ay, ay, ay. Well, it's not a quadratic. It's not 4 terms, so I can't write it factor by grouping like we did on the other one. Can't do that. It's definitely not a sum of cubes or difference of cubes. I do notice it's a trinomial, and my first term's a perfect square, my last term's a perfect square, and c is positive. So could it possibly be a perfect square trinomial? Yeah. Can we just assume that it is by those 4 things I mentioned? No, but we can test it out. So what's the square root of the first term? 4, you got to look at your variables too. 4 m squared. What's the square root? Oh, I said 81 to the 4th. I missed something. 81, that should be 81 n to the 4th. What's the square root of the last term? 9m squared. So if I multiply those two together, I get 36, that's n, m squared n squared. That's not my middle term, but I still need to do one other thing, which is what? Double it, and you're just doubling the coefficient, right? 36 doubled is 72 m squared n squared. So is it a perfect square trinomial, and it doesn't matter what that sign is? Yes. But we know how to factor those really easy. Perfect square trinomials have 2 identical factors. So we just make one set of parentheses and we square it. The sign is the sign of the middle term. The first term is the square root of the first term. So that's what? 4m squared. The last term is the square root of the last term, which is 9n squared. Okay. What do you notice about this? It's a difference of 2 squares, right? 4m squared is a perfect square, minus 9n squared is a perfect square. And there's 2 of these. There's 2 of these. So it might be less confusing in this case since we have to factor it further. And you don't want to forget it. You don't want to go, oh, okay, so it's 2m plus 3n times 2m minus 3n. Well, technically that's 2 times because this is 2 difference of 2 squares, right? So maybe it would be easier to write that out since we have to factor it further. Just write it twice and then factor it. Y'all see what I'm saying? So to factor this binomial, that's going to be 2 sets of parentheses. And then to factor this binomial, which is a difference of 2 squares, that's going to be 2 sets of parentheses. So let me just do the first one first. I get 1 plus 1 minus, what's going to be my first term? 2m, what's my last term? 3n. And so this is 2m minus 3n. And we have the same thing over here. 2m plus 3n, 2m minus 3n. Before we take the PERT again, I want y'all to come back and review these notes, because if you're getting higher up, if you're passing, getting questions right, and start factoring the higher level stuff, you're gonna need to remember how to do this. Okay, so this is a lesson I want you to come back to and review, which we'll do some reviewing beforehand, but I think this is important. Anything that has to do with factoring, important on the PERT. Can I factor anything else any further? No. I'm finished. Next example. (27x cubed plus 64). Sum of cubes, you're right. Does it have a GCF that I could take out first? No. But you are correct. It is a sum of cubes. Do y'all remember the identity, or do we need to write it in our notes? Not times 2 on that one. That's perfect square trinomial. Just minus AB plus B squared. All right, let's write it down in case you don't remember it. So sum of cubes is a perfect cube plus a perfect cube, right? To factor it, in the first set of parentheses, you take the cube root of the first term, so the cube root of A cubed is A. If it's sum, you have plus. To get this term, it's the cube root of the last term, so the cube root of B cubed is B. In the second set of parentheses, it's going to be a trinomial. Whatever the first term is in the first set, you square it. The sign is opposite of what it is in the first set. Middle term, you multiply these two together. So A times B is AB. You always add the last term for sum of cubes, and then you square the second term to get the last term. Okay? So my first set of parentheses, what is the cube root of 27x cubed? 3x. What's my sign? Plus. What's the cube root of 64? 4. Second set of parentheses, the first term, I have to square the first term in the first set of parentheses. 3x quantity squared is what? 9x squared. The sign is now opposite of what it was in the first set. To get the middle term, you multiply the numbers in the first set. So 3x times 4 is 12x. Last term you add b squared. So that second term in the first set of parentheses, you got to square it. So 4 squared is 16. So 3x plus 4 is linear. We know we can't factor that. And I told you that you're always going to get a quadratic in the second set of parentheses for sum of cubes or difference of cubes. But I've never seen it be able to be factored. Okay, so you can try it. But I've never been able, it's never been factorable. All of the sum of cubes, difference of cubes, I've done in my time. All right? So probably don't worry about wasting your time trying to factor that. But it is quadratic, so you could check it, but it just doesn't usually work. Any questions on that? Example 7. I should have done each example in a different color. Not on my game today. Okay, we have 2a cubed minus 16. Is that a difference of cubes? It has a GCF. So right now that's not a difference of cubes, difference of squares or anything, right? But it does have a GCF. So let's take that out and see what that does for us. And our GCF is 2. So if we take out a 2, 2a cubed divided by 2 is negative 16 divided by positive 2 is Now we have a difference of cubes, right? What's inside parentheses is a difference of cubes. So we have to factor it further. So difference of cubes, the identity is very similar to sum of cubes. Only thing's different is two of the signs. So difference of cubes we have would be like a cubed minus b cubed. Perfect cube minus a perfect cube. To factor, first set of parentheses would be a minus b. Second set is a squared plus ab plus b squared. And I just explained all that up top. Only thing different is the sign in the first set of parentheses and the sign of the middle term. The sign of the last term is always positive. We cool with that? So don't forget your GCF on the outside. In my first set of parentheses, what am I going to have? A minus 2. Cubed root of the first term, cubed root of the last term, it's minus. Next set of parentheses. A squared plus 2a plus 4. Very good. This quadratic, I would need two numbers that multiply to get 4, add to get 2. It's not possible. It can't be factored any further. And we're not solving these. If I was solving, I could use quadratic formula. But I'm not solving anything. Okay? If I were graphing this and I had to solve these to figure out where my graph would cross the x-axis, I know it would cross at 2, but here it's going to cross somewhere, but I would have to use a quadratic formula to figure it out because I can't factor that. Coolio? All right, let's look at example 8. M squared n to the 6th plus 16 mn cubed plus 64. Is there a GCF? No. Okay. Is it a quadratic where I could try T chart and divide and slide? Is it a sum of cubes? Difference of cubes? Difference of squares? What else is there that I could check? Is it a perfect square trinomial? Let's check it out. Okay. We can see my first two terms of perfect square and the last two terms of perfect square, or the last term. It's a trinomial, C's positive. But we have to check the middle term. So what's the square root of m squared n to the 6th? Mn cubed. Very good. We're going to multiply that by the square root of the last term, which is 8. So when you multiply those together, you get 8 mn cubed. And then we have to double it to see if we get the middle term. So that is 16 mn cubed. Is it a perfect square trinomial? Yes. Okay, so we make one set of parentheses and square it. The sign is whatever the sign of the middle term is, so plus. Square root of the first term is my first set of parentheses. So we already said the square root is mn cubed. The square root of the last term is my last term. Is that a sum of cubes? If I did not have the m, that would be sum of cubes, and I could factor it further. But is mn cubed a perfect cube? No, if that was mn and there was parentheses and the 3 was outside the parentheses, that means they would both be cubed. But only the n is cubed here, not the m. So that's not sum of cubes. We can't do anything with that. Okay? Anybody have questions? So I'm ready for that second sheet of notes. I had a feeling we were going to need it. It's the same topic, just more examples. Okay, so this is still section 6, topic 7. So we can just staple these together. So this is example 9. I'm going to do different colors on this page. Is it really 9? Yeah. 10a to the 5th minus 4a squared b plus 15a cubed b minus 6b squared. So I'm trying to lead you through the same questions that I want you to ask yourself when you're factoring. First of all, is there a GCF? 10, 4, 15, and 6. Do we have one in the coefficients? No. Does each term have at least one A? No. Does each term have at least one B? No. So is there a GCF? No. When you see 4 terms, you know it's not a difference cube, sum squares, or a perfect square trinomial, right? When you see 4 terms, what do you automatically think? Factor by grouping. So I'm going to group my first 2 terms together and my second 2 terms together, and I'm going to treat them like 2 different problems that I'm factoring out the GCF of. Okay? So let me do this. In my first group, remember, even if the GCF is a 1, that's what you take out when you're doing this method. What is the GCF of the first group? 2a squared. No b's? No b's. So I'm just going to divide those 2 terms only by 2a squared. Be careful with your exponent rules and everything else, all your signs, all that. So 10a to the 5th divided by 2a squared is 5a cubed. Good. What do I get when I divide the second term? Minus 2 what? B. Minus 2b. A squared divided by a squared is 1. We like to say it cancels. Okay? Now look at your second group. We're treating it totally different. Whatever the sign of the first term in that group, that's the sign we're going to use. If it's positive, we'll use a positive. If it's negative, we'll use a negative. What's the GCF of that group? 3b. So 15a cubed b divided by 3b is 5a cubed. Negative 6b squared divided by 3b? Negative 2b. What's inside parentheses? Is that the same? This is one term with 2 factors. This is one term with 2 factors. Okay? Is there a GCF within those terms? Don't they both contain a 5a cubed minus 2b? Okay, so when you get to this point, make 2 sets of parentheses. Put what's in parentheses in one set. That's like you're taking out the GCF, okay? What's left on the outside, group those together in the other set. So 2a squared plus 3b. Don't overcomplicate it. And a lot of kids, why do you only write that once? There was 2 of them. It was our GCF. We took it out. When I divide this term by 5a cubed minus 2b, we only have 2a squared left, right? You put what's left in parentheses. When I divide this term by 5a cubed minus 2b, we only have a 3b left. This is the GCF. We're not used to it looking like a binomial, but it can be a binomial. Can I factor either of those any further? No. Coolio. Let's try this one. It's example 10. I think we've ever done this many examples on our notes. 15x cubed y minus 27 x squared y squared minus 6xy cubed. Is there a GCF? What is it? 3xy, very good. So GCF goes on the outside, and we factor each term by the GCF to figure out what's left. So 15x cubed divided, or what's, when I divide the first term, what do I get? 5x squared. The y divided by y's, that's what had one y, took it out. X squared divided by x. All right, what do I get when I do the next term? Minus 9x y. What about when I factor the last term? Very good. What's inside parentheses is a quadratic. I have two quadratic terms. So if the first term has x squared, the last term's y squared, so they're both squared, and the middle term has one of each, then we're going to factor it like we do a quadratic. Okay? Only thing the difference is first term's going to have an x, the second term's going to have a y. So we know that a is 5, b is -9, and c is -2. So we need two numbers that multiply together to give us AC, which is -10, and add to get B, which is -9. -10 and +1. -10 times +1 is -10. -10 plus 1 is -9. All right, so that works. So we have that GCF on the outside. Make two sets of parentheses. We'll put a x in the first and a first set of each term, and we'll put a y in the second set of each term. And look at our t-chart for our numbers. So we'll do a x minus 10y and an x plus 1y, which we know we don't have to put the 1 there, but when we divide and slide it will probably make it less confusing. Well, do we need to divide and slide? Yes, because a is some number other than 1. Do we divide and slide the GCF? No, only those two numbers that we got from the t-chart. So 10/5, is that going to be a divide or a slide? How about 1/5? A slide. Can I reduce it? No. So we will have 3xy times x minus 10y divided by 5 is 2y. In the second set, slide the 5 over and have 5x plus y. These are both linear, so we just have to double check, make sure there's no GCF. If we took out the greatest GCF at the beginning, then there shouldn't be. But can I do any more factoring? Nope. Example 11. Eight u to the 6th minus 50 v to the 8th. Is there a GCF? What is it? What? 2. So I'm going to take out the 2. 8u to the 6th divided by 2 is 4u to the 6th. Negative 50v to the 8th divided by 2 is negative 25v to the 8th. Inside parentheses, difference of two squares. Right? 4u to the 6th is a perfect square, 25v to the 8th is a perfect square, and there's a minus sign. So we know to factor that. Put your GCF on the outside. Make two sets of parentheses. One gets a plus, one gets a minus. The first term in each set is the square root of the first term. So what would that be? 2u cubed. Remember, 6 is a perfect square and a perfect cube. If I said cube root of u to the 6, what's that? U squared. But square root is u cubed. And what's the square root of 25v to the 8th? 5v to the 4th. Is this a difference of squares right here? No. 2u cubed, is that a sum of cubes or anything? Difference of squares, anything like that? No. So I can't factor any further. And there's one other type that I haven't shown you yet. We'll do that on the back side. So this would be example 13. 12. M to the 4th plus 13m squared plus 36. Is that a sum of cubes, difference of squares, perfect square trinomial? M squared times 6 is 6m squared, doubled is 12m squared. No, okay. Can we use T-chart and divide and slide? Nope, it's not a quadratic. However, when you have a problem like this, it's a trinomial. Your first term has a degree of 4. Your middle term has a degree of 2. Oh, is there a GCF? No, we always look for that, right? And your last term is a constant. You can factor this just like you do with T-chart and divide and slide. Okay, you factor it like a quadratic. So the first term has to have 4 degrees. Your middle term has to have 2 degrees. And your last term has to have 0 degrees. I think you can also do it with 8, 4, and 0. I don't want to get too complicated. So we factor like a quadratic. So T-chart and divide and slide, right? We know A is 1, B is 13, C is 36. So my T-chart, I need two numbers that multiply together to get A times C is positive 36, and add together to get B, which is positive 13. 9 and 4. 9 times 4 equals 36. 9 plus 4 equals 13. So in my parentheses, instead of putting m as the first term in each set, what do you think I put? M squared. And then I have a plus 9 and a plus 4. Can I factor those further? No. If those were both minuses, I could, right? They'd both be a difference of 2 squares. And actually, these are both sum of cubes, so I could factor and get imaginary factors. We'll learn that in a couple of lessons. But from what we know right now, those you cannot factor these and get real factors, okay? But you can get some imaginary ones. So for now, that's as far as you can go. So don't let these confuse you. You factor them just like quadratics, but it has to be 4 degrees, 2 degrees, 0. And make sure that first term is m squared. So think about it. If we multiply this out, m squared times m squared is m to the 4th. M squared times 4 is 4m squared, times 9 is 9m squared, 4m squared plus 9m squared is 13m squared, and 9 times 4 is 36. So it works out, right? So I'm just going to do 2 more quick ones like this so you have them in your notes. A to the 4th plus 3a squared minus 10. Is there a GCF? All right, again, we have 4 degrees, 2 degrees, and 0 degrees. So we can factor like a quadratic. T-chart. Two numbers multiply together to get A times C is negative 10. Add together to get B is positive 3. What did I heard it? What was it? 5 times negative 2. Positive 5 times negative 2 is negative 10. 5 plus negative 2 is positive 3. Perfect. So 2 sets of parentheses. This time, what's going to be my first term in each set? A squared. And then I'll put a plus 5 and a minus 2. Well, I need to divide inside? No, we didn't write A, B, and C out, but A was 1, right? One more. Now, y'all have done a lot of work today. 3a to the 4th plus 13a squared plus 4. Is there a GCF? No. Can we factor like a quadratic? Yes. 4 degrees, 2 degrees, 0 degrees, right? Doesn't mean it's factorable, just like a quadratic's not always factorable. But if it is, that's how we can factor it. So A is 3, B is 13, C is 4. We need two numbers that multiply together to give us AC, which is positive 12, and add to get B, which is positive 13. 12 times 1 is 12. 12 plus 1 is 13. Perfect. So first term, A squared. Then look at our T-chart. We have a plus 12 and a plus 1. Will we need to do divide and slide? Yes. 12/3 divider slide. 1/3 divider slide. Can I reduce? No. Okay. So that's going to be A squared plus 4. Put that 3 in front of the A squared. Slide it on over. 3A squared plus 1. Now, if that was A squared minus 4, we could factor that further. Okay? If we knew how to factor sum of squares, we could factor it further if we get imaginary, but we don't know how to do that yet. And 3a squared plus 1, two numbers that multiply to get 3, add to get 0, it's not factorable, so there's nothing else we can do. Okay? Any questions? I know there's a lot of different types. When you're factoring on your own, go through all the questions, okay? If it's just two terms, look at it. Is it sum of cubes, difference of cubes, sum of squares? Is there a GCF? If it's 3 terms, is it a quadratic? T-chart, divide, and slide. If it's 4 to 0 degrees, factor it like a quadratic. If it's 4 terms, factor by grouping, right? 3 terms, it might also be a perfect square trinomial. So you got to go through all of those questions in your head to help you. All right, let me pause this. Don't remember how.